of a rectangular window is 2 times its width. Okay, so here's the width, here's the length. We know that the length, whoa, what's going on, pen? Oh, there we go. We know that the length is 2 times the width. Write an equation that will determine the dimensions. If the area, so the area equals 146 inches. Okay, so we know that area equals length times width. We know that the area is 146, so 146 must equal length times width. We know that the length is twice the width, so we can substitute this to W. We can do a little substitution in for L. So 146 equals 2W times W. So I'll bring our work right up here. So 146 equals 2W squared. We'll divide both sides by 2. That will give us 73 equals W squared. Am I doing that right? 73 equals W squared. And then to find each side, we'll just square root both sides, and whatever answer that is will be W. It'll be between 8 and 9. Your answer will be somewhere between 8 and 9. I don't know where it will be, because 8 times 8 is 64, 9 times 9 is 81. Okay? And let's look at 18. The area of the front of a cabinet is 48 square feet, so that's the area. The width is 3 times as long as the height. What equation will determine... Oh, and it's just asking for the equation. Oh, so here's your equation right here. That's the answer. Don't worry about any of that. What is the equation that will determine the dimensions of the cabinet? So W equals 3H, so the width equals 3 times the height. And we know that the area is 48 feet squared. So area, we know area is width times height. And we also know that the area was equal to 48, and therefore, so 48 must equal W times height, and we saw up here that W equaled 3H, so 48 equals 3H times H. So you could even leave it like that if you want to, and that'll find you the height. And that's good enough for me. Okay, let's go down to number 19. The length of a rectangular pool is 4 times its width. So here's our rectangular pool. The length is 4 times the width. So L equals 4W. Which equation will determine the dimensions if the area is 80 meters squared? Okay, so it's going to be, let's see here. So 4W times W equals 80. So 4W squared equals 80, which is C. Because we just did, this was our length, this was our width, and we knew that length times width equaled our area, and our area was 80 meters squared. So 80 square meters. So I just substituted because it told us our length was 4W. So 4W times W is 80. 4W times W is W squared. So 4W squared equals 80. And that matches C. Alright, let's move along to number 20. The area of the front of a cabinet is 18 feet squared. 18 feet squared. The width is 3 feet longer than the length. So here's the length and here's the width, which is 3 feet longer than the height. What is the equation that will determine the dimensions of the cabinet? Okay, well we know that this side times this side will equal this area right here. And we know that this side is 3 plus h. So if we take 3 plus h and multiply it times this side, h, that will give us the area, which is 18. So there's your equation right there. You just need to realize on these, you just need to know that area is equal to length times width, and that you'll probably do a real basic substitution. It just told us that the width is equal to 3 feet longer than the height. And so that's all we substituted in right here. Okay, looks like we have some good factoring problems ahead of us. Factor completely. Check the GCF first. Okay, so let's go ahead and factor these. Here's a GCF. So 4 goes into both of those. X goes into both of those. So 4x is the greatest common factor. So 4x times what is 4x squared? Well, that would be x. 4x times what would be 16x? Well, 4. Okay, so there's your answer there. The answer here is 4x times the quantity x plus 4. Okay, let's come over here. Okay, so this is a sum of squares, so we cannot factor that. There's no common factor. This is prime, I believe. Okay, let's go to 23. (16y squared minus 492). Okay, I have a suspicion that 492 is a perfect square. Let's see here. Let me just do a little calculation. I don't have a calculator on me. Just want to see if that is a square. Hmm. $492. $492. Where's the square root? Is there a square root on here? Whoa, no. We factor. Oh, wait, hold on. Let's factor out a 16 from 492. 492 divided by 16. Nope, can't factor anything out there. Factor out a 4. Oops. Let's factor out a 4. Let's factor out an 8. Let's try 492 divided by 4. Okay, so there we go. We found the factor. The greatest common factor between 16y squared and 492 was 4. So we saw that 4 went into, so 4 times 4y squared will be 16y squared, and then 4 times, what was it? Was it 123? Was that right? Yep, times 123. This is the factorization of number 23 right here. Okay, number 24, we recognize it as a difference of two squares. So we can use our setup here and go 4n squared. The square root of that first term is 2n. 2n. Our signs will be different. And the square root of 16 is 4. So that is our difference of two squares formula. Okay, and now let's look at number 25. Looks like before we even start, we can actually factor out a 2. So let's factor out a 2 from all three of these terms.